In this video, I'll describe how grids help the artist, and it's in my book, Ellen's Guide to Drawing Shapes on Amazon. Let's divide a rectangle either parallel to the picture plane or in perspective. So start with the rectangle and draw diagonals to find its center. And then draw a vertical line through that center so that now we have this pink rectangle and the green rectangle, two rectangles that are smaller than the original. Now this is much more useful when we're using it in perspective. So draw the trapezoid with true vertical lines and draw its diagonal so we can find the middle of this trapezoid. And now we have divided it into two squares. The front one, number 1 here, which is larger than the second one over here. So instead of dividing a rectangle, we're going to multiply them. So start with this rectangle parallel to the picture plane with true horizontal and vertical lines. Find its center, and then find the center of its side using this horizontal line. And then draw the diagonal from the top corner here through the middle of its side and find where it hits the baseline over here. And that will be the end of the pink rectangle that goes like this. So we have multiplied this one rectangle into two. To multiply rectangles in this receding shape, find the green diagonal that travels from this top corner through the middle of its side to the base. And where it hits the base is the beginning of the new pole. Multiple green diagonals like this will create a set of vertical lines that get closer with distance. And this diminution with distance is sometimes hard to judge, making this method very useful. This is the easiest way to draw a grid in one-point perspective. So start with the horizontal measuring lines where you mark off equal units, and then draw converging lines from each unit to the central vanishing point. Then draw a diagonal, and where that diagonal crosses the white lines are points that mark the positions of these horizontal green lines. If we move the diagonal to the right, we would compress the tiles. Here, to find these converging lines, instead of using a vanishing point, I divided each side of the building into a measuring line with the same number of units, and then connected each unit together. Then I drew a green diagonal, and where that diagonal crosses these red lines would be a position of the vertical line. When putting in the reflection, don't have it follow the grid exactly, so it doesn't look like it's an intrinsic part of the building. Drawing hexagons in perspective is a little more complicated, but can be accomplished using the same method. So start with this measuring line with equal units and draw lines converging toward the vanishing point. Again, you could have this back one as a measuring line with the same number of units and just connect like units together. Then draw this diagonal line, and where the diagonal hits the white lines, like here and here, are the position of these pink lines. So at this point, we have identified 3 to 5 corners of the hexagons marked with these navy blue dots, and that's probably enough to finish the pattern. Alternatively, we can use a grid where we have 3 vanishing points, and the white vanishing point here is halfway between the other two. Where the blue, red, and white lines meet at these yellow dots mark the position of these yellow horizontal lines. Now we can use this to form pentagons here, and you can see that one row of pentagons point down, and this row points up. We can also use it to create hexagons, and here are some hexagon tiles. And then we can also use it to form octagons. But the thing with the octagons is that you're going to have little black diamonds in between them. How do we draw a vertical grid instead of the horizontal one I just showed you? So let's again set up the measuring line with equal units and draw converging lines to this left vanishing point. Then draw this diagonal, and where it hits the pink lines mark positions where the white verticals should lie. This white vertical determines the size of the rest of them because they all converge toward the diagonal vanishing point. But now we need another measuring line, and this time vertically. And we would use this vertical pole in front because it's on the picture plane, so it has true lengths, not those in perspective. We could use the same units as on the horizontal line, in which case these would be squares with equal sides. Alternatively, the vertical measuring line could have different units so that we would have rectangles instead of squares. Now draw lines from each of these vertical units to the diagonal vanishing point to finish the grid. So if you look at this now, we can see that the horizontal measuring line determines the spacing of these vertical white lines, whereas the vertical measuring line here determines the spacing of these horizontal converging lines. So as I've shown you, diagonals are critical toward establishing these grids, and here's why. Let's say we have rectangles with the same proportion. Let's say this is x and this is 2x. Well, this next one is the same proportion because this height is x and this length is also 2x. So when you have rectangles with the same proportion, their diagonals are parallel. Rectangles with different proportions have diagonals that are no longer parallel. Since these diagonals go to the same diagonal vanishing point on eye level in perspective, we can use the diagonal vanishing point to find these boxes with the same proportions. So this particular method is really good because the length of the box and the length of the space in between can be anything you want. They don't have to be equal. So start with the bottom corner here and go to the top corner and find the diagonal vanishing point on eye level. Then for the next box, determine where you want it to start, and then where it crosses the top line would be the end of the box as this goes to the same diagonal vanishing point. The only problem with this method is that the diagonal vanishing point is usually well out of the picture. In my next video, I'll discuss more about one-point grids and give you some examples. And please remember to subscribe.